Hello and welcome to another Animation Nodes tutorial. In this video I will show you how to use the new Find Shortest Path node to create things like these. If you're familiar with my channel, you know that I already have plenty of tutorials on animation nodes on here, and there are a few questions I get frequently from viewers, so let me just take a couple of seconds for some basics here. First, download the latest Blender version from blender.org. I'm actually using Blender 2.83, which at the time of this recording is still in alpha. You can find alpha and beta versions by scrolling down and clicking on Download Blender Experimental. The first concern people seem to have is with installing alpha or beta versions, but you can have many different Blender versions on your system. Simply unpack the downloaded file to a location of your choice and start the Blender executable, in my case blender.exe in Windows. Always make a copy of important .blend files before using them in alpha or beta versions, since they might get destroyed. The second thing you need is of course the add-on Animation Nodes, which is free first of all, and you can find current builds for the latest Blender versions, even including some extra nodes, at blender.community in the Graphical section. Then you open Blender, go to the Preferences and the Add-ons tab and click the Install button. Select the add-on file you downloaded from Graphical and enable the checkbox, just like with any add-on in Blender. Now you are ready to follow along this and many other Animation Nodes tutorials on my channel. Alright, so here I am in 2.83 alpha, like I said. I'm just going to delete everything, and in order to show what this new node does, I think I'm just going to take a low poly icosphere. And then I split the screen here, open Animation Nodes, and create a new node tree. Hit T on the keyboard, and I always switch off this always option here from the auto execution part and switch on these three. Now let's put in the new node, which you can find in, by the way, you press Shift A, just like anywhere in Blender when you want to add something. And you can find it in Mesh and then Operators. And there's the Find Shortest Path, or since we already know that the node is called Find Shortest Path, we can hit Ctrl A and just type in short. And there it is, Find Shortest Path. And this looks like a funny little node because it takes a mesh and it creates a mesh, and it also takes sources. So let's see what that is. Okay, so first we need a mesh. We want the icosphere, so we have to take the mesh input. Just eyedropper in our icosphere and plug the mesh in here. And now we need sources. What is sources? Well, if we go into edit mode, our mesh has vertices. And basically the sources is a list of vertex indices. So we need a number integer list. Plug that in here. And just for clarity, I'm gonna delete that second input element. So I just have one element in a list, and I plug that into the sources. Okay, the Find Shortest Path node uses this list to select vertices, and that's where it starts to create the paths to all of the other vertices. And since this is a list, this node can start from multiple vertices, so not just one. Let me show you what I mean. How can we visualize what we're doing? Well, we could take a list, get element node, maybe take this list, output a list, and then take a viewer, 3D viewer node, plug that in here, maybe make it red and increase the size. I also have to plug in my list here. So that means that the vertex with the index 0, which I selected here, is this one. If I select vertex index 1, it's that one. Okay. So I can select which vertex that the Find Shortest Path node should start from, or I could even take this, add a new input, and then select another one. So we have two sources now selected. Now what does the Find Shortest Path node do? So down here, this is just for visualization now. What does it do? It creates a mesh. So let's create a mesh. Mesh object output. we create a new object, which is called target. We plug in this mesh and we enable the mesh, and then we can hide our original icosphere. And we can't see anything. Sometimes you just have to select the target, go into edit mode. And that's what it does. Okay, so it creates paths, or actually it creates edges inside of a new mesh, starting at the selected vertices here. And then it finds the shortest path to all the other vertices, starting from this one and this one. So we're not overlapping here. For example, if this one goes to this vertex, then starting from here, this one doesn't have to go to this vertex anymore. That's why we have this separation here now. Okay, so what can we do with this now? Of course, you know, if you only have edges, none of this really renders. So this is basically invisible. You could add a skin modifier to this so that you get geometry that you can actually render. Or instead of creating a mesh, let's just delete this node. Let's also delete this target object. Let's show our icosphere, maybe pick another vertex here. These two, okay. So instead of creating a mesh, we're just gonna create a spline from edges. Okay, so we're gonna create a curve, a spline. We want a spline per branch, but we need vertices and edge indices, and we can get that from a mesh info node. So we basically split apart all the mesh info into vertices and edge indices, which gives us a list of splines. And what can we do with that? We could simply create a new output object, which again is called target now. Plug in the splines, enable the splines, and again hide the icosphere. So we have this now. This is not a mesh now, this is actually a curve. And we can go into the curve settings here and set the resolution down and increase the bevel depth. So now we have this. And that is really all there is to it. This node does all of the work, and this is just to create something that we can actually render in C. In this case, we have pipes. Now there's one cool thing that we can do, because now we have curves. We can add a spline trim node in here. And when we do that, we will realize quickly that if we animate the start value here, we can see by animating the start, we're actually animating the end. And that is because, although it looks or it seems like the curves start at our selected vertices, the two red dots here, the find shortest path node creates splines that actually start at the end here and end at the selected vertex. So this here is actually the start. One other thing we have to realize is this find shortest path node creates a spline from the vertex that we select to each vertex. So although this looks like we have one spline going here and one going here, there's also one going just to this vertex and over here as well. So we have one going to this vertex, we have one going here and then here, we have another one going here and then here and then here, and they're all overlapping, but of course with this visualization we can't see that. But we have to keep that in mind. Okay, and this really is, without this really is all you need. You plug the mesh into the find shortest path node, you get a new mesh. You can rip that mesh apart into its vertices and edge indices and create splines, do some cool stuff with the splines, and then create a new object here. plug in those splines, and you're done. If you want more pipes or more details, of course, you have to increase the mesh data, the poly count of your original object. So let's unhide the icosphere and hide the target. Let's go in here, maybe press Ctrl 1 to add one level, or let's press Ctrl 2 to add 2 levels of subdivision. Apply that. Let's pick something here. Index 100, index 18, maybe start at a third position too, index 250. And then hide this, show the target, and you can see now we have this cool looking thing. So with this feature, it's very easy to create cool looking sci-fi stuff. And I think sometimes the patterns that the find shortest path node creates are very interesting looking. In this animation right here, you can obviously see that the growing animation, all the paths, all the pipes start down at the toes. So let me just show you a trick how you can find the indices you have to plug in here. And you know what? I'm just gonna actually maybe start fresh, delete the icosphere, hide the target object, and really create a character model. Again, just like in my last tutorial, I hope you've seen it, about the cloth sims. I'm just gonna create a new character using the Manuel Bastioni lab. Just click create character and it gives us a character like this. We can switch off the armature so it's not in the way. Oops. And then by selecting it, I can go in here and let's check out what the modifiers are. So we have the armature, which is okay. I'm just gonna apply it. Apply the corrective modifier. No, I'm just gonna delete the subdivisions so we don't have too many polygons. So this is the base resolution here. That's plenty. And displacement we can delete. Okay, so now we have a mesh. And if we wanted the animation to start, let's say at the fingertips here on the thumb, I want to start my find shortest path right here at this vertex. How do I find out what the index is of this vertex? If you know if there's a simple way in Blender to get this information, I couldn't find any, then please let me know in the comments below. I'm just going to show you what I did. So I have selected this one vertex and the object is also still selected. And I'm going to split my screen here, go to text editor, create a new script, and then just paste this short little script in here. So let's see what that does. It takes all the vertices from the active object and iterates over those. And if the vertex is selected, then it puts the index of that vertex into this variable here, which is going to be a list of vertex indices, and then it just prints that out. So I have that one vertex selected. I have the character here selected. I have to go to Window Toggle System Console, which opens this screen. And then all I really have to do is hit the Run Script button. And in the video, in the window here, we can see that this vertex that we selected has index 7258. Okay, let's go back into edit mode and maybe shift select this one too. So now we have 2 vertices selected. Hit Run Script again, go to this window, and now we have 910 and 7258 in the list. So I'm going to eyedropper my character in here, and I'm just gonna put in 910 for my first index. And by the way, you can select this node, hit N, and then over here you can remove inputs. So I just need 2 here. what was it? 7,258. So those are the two indices that I need. And now I can hide this and hide this character, show the target object, and we already have all those pipes starting at the fingertips. Now this is a little bit thick, so let's turn that down to something like this, and you can see that we're starting here, visiting every single vertex on this mesh, all the way down, all the way up to the head. And we have pipes because our target object here has a bevel depth assigned to it. Maybe we can turn that down even more. Now Blender is very slow now because remember, this is not just what you see now, but there's a curve going to each vertex starting from this vertex here. So there's one going to here, there's another one going here and then here, there's another one going here, here, and then here. So there's a lot of stuff in this scene right now. And again, we could animate this. So if I enter 2.5 in here, then we only have the curves going this far. And if we animate this up using, for example, the animation time info node and then a map range node, we could animate our frame info between 0 and let's say 250 frames, which we have on the timeline here, to what is it, start 0? No, we start at 1 and we end at 0. We plug that into the start value. Remember, the curves are actually going from the vertex to our source. And then I'm just going to manually execute the node tree. So at the first frame, we have almost nothing, just this. At frame 130 something, execute, we get this. And then at the end of our animation, the entire body is visible. And that is exactly how I created this animation. Okay, how can you do something like this, where you have like a glowing end of the curve? So let's get rid of this maybe, delete hierarchy, hide the target object. Let's start with a simple plane maybe, go into edit mode, subdivide like, I don't know, 50 times. So we have this grid. Then we go in here, select maybe something in the center, select this vertex and run the script again. What's the output? The output is 1528. So here we're gonna get rid of the second input and enter 1528. You can switch on auto execution because the poly count is not very high here. Now if I hide the plane and show the target, I have to put the plane in here, of course, then we get this. Now this is not very interesting looking, but of course that's what we get, because in our mesh the shortest path from our selected vertex to this one is just a straight line, and then here it's a straight line. So of course this is really just the shortest paths to all of the vertices starting from the one that we selected. Now how can we make it look a little bit more interesting? Let's show the plane, go into edit mode and add a modifier, and I find that the decimate modifier is set to collapse, and then you take down the ratio quite a bit. Or, you know, we could go into object mode and enable wireframe. That gives you this, and that looks much nicer, especially when we use the find shortest path node. And also I find that triangulate gives very nice results. So let's apply that and execute this node tree again. Oh, of course, some indices are out of range now. I have to go in here again, select a vertex or many. Let's take this one and that one. Okay. Then we run the script. Check in the output window. 255 and 510, 255, 510, 510, and hide the plane. And then we get this very organic looking cool thing. And now it's not as boring with all the straight lines. Now it looks kind of interesting. But that's not really what we're here for. We want to know how to make the glowy parts. So we have pipes and I gave them some thickness. We're animating those pipes still with our time info map range to change the start of the trim spline node. Now let's create the particle that actually has the glowing material at the end. So I'm gonna split the screen here. Maybe bring this over so we have a little bit more room. Switch this to rendered view. Make the background black. Switch off the overlays. Maybe add a point light so we can see something. And then I'm going to add a mesh icosphere. In edit mode, scale it down and make it really, really, really small. In fact, I have to make it smaller than the diameter of my pipes. Okay, so something like this, just a little bit smaller than the diameter. Okay, Alt G to bring it back to the center. Now this guy is gonna get a new material. I'm gonna set this to emission, turn up the strength and switch on bloom so that it looks cool. Maybe give it a red color and turn up the strength even more. So now we have a glowy dot here. Let's move this guy out of the frame. And now in animation nodes, which creates these splines, we're gonna find the end of each of the splines. And that's really easy to do. We can go to spline evaluate. The evaluate spline node takes a single spline, and then we have parameter, which is basically between 0 and 1. 0 being the start of the spline, 1 being the end of the spline, and it gives us a location. But this can't take a list of splines, so we have to create a little loop. Just go to Shift A, subprogram, loop. Gives us a loop input. We need a new iterator, which is going to take a spline list. Now here we have each spline, but we have a single spline, which we can plug in here now. We will evaluate the location at the start. Remember, the start is actually the end. So the start will be here. Let's evaluate the spline at location 0, which gives us a location. And then what we need is a whole bunch of our glowy dots. So out here, maybe we create an object instancer. How many instances of our glowy dot? The glowy dot is icosphere 1. How many instances do we need? Well, just as many as we have splines. So we can plug that right in, and animation nodes adds a get length node for us. So now we have a list of glowy dots. We can also plug that list into our loop input, so object list. Now let's hit W, create invoke node, which invokes our subprogram, our loop. And we can give it the list of splines, and we can give it the list of glowy dots. And inside of the loop, all we really have to do now is transform input. We have to do transform output. We want to transform the location of one glowy dot to this location. And here we go. So we're creating the pipes. We're animating the pipes. We're making them grow. And we're placing glowy dots at the ends of each of the splines. Now, why did I make the dot so small? Let me demonstrate. Here's the glowy dot. Let's go into edit mode and scale it up. And here you can see that our find shortest path node creates a path to each vertex. There's one going to this vertex, and here we have the glowing dot. And there's one going to this vertex, and we have a glowing dot. And in order to only see them at the ends, all I did was make the glowy dots small enough. So now there's glowing dots in there everywhere, but we can't see them because they're so small. Alright, that is it. One tiny new node in Animation Nodes can give you all kinds of possibilities for interesting, organic looking images or motion graphics. I hope you like this effect and will give it a try also. If you do, please tag me so I can admire your artwork as well. If you want to see more free tutorials on the amazing add-on Animation Nodes, then go ahead and browse through my channel right here on YouTube. Subscribe if you like my content, and if you want to download the finished blend files of these animations, you can find them on my Patreon. Thanks for watching. Chris P out.